Hi, Maths 2 students. Welcome back. We're just going to work the Practice Benchmark Chapter 7. So let's start with the first one. Find the lateral area. So this is all going to be surface area, lateral area, and volume. And I did make a worksheet with all of the volume, surface area, and lateral area formulas. I posted it in Module 2, I believe. So go look at that, print it out if that helps you. All right, we're going to work on the lateral area and the surface area here. Let me get the pen working. And here we go. Draw. All right, we're going to look at the lateral area and the surface area of this box to the nearest whole number. So let's go ahead and look at the lateral area first. So the lateral area is all the sides, not the top or the bottom. And we know the lateral area formula for a prism is just the perimeter of the base times the height. Now you could go ahead and do the area of this face and go this side times this side, and then do the back and then this side and this side. Or you can take a shortcut and do the perimeter of the base times the height of this. And it's going to do funky things. All right, so the perimeter of the base, 4.8. This side is 1.9. The back side here, this back side will be 4.8 also, and this side will also be 1.9. So we'll go 4.8 times 2 plus 1.9 times 2. And that will be the perimeter of the base. Go ahead and work that out. If I do 4.8 times 2 plus 1.9 times 2, I'm going to get 13.4. All right, so there's my perimeter of the base. Now I'm going to multiply that times the height. And the height here is 2.2. So when I multiply that out and just use a calculator, I'm going to get 29.48. And to the nearest whole number, that would be 30. That is in feet. It is area, so it's feet squared. And that is your lateral area. So here's my lateral area. Now let's look at the surface area. The whole surface area is going to be your lateral area, which we already have, plus 2 of the bases, the top and the bottom. So the area of the top and the area of the bottom. So we just need to find the area of the top and the bottom and then add it to our lateral area. So we already know this is 30 plus 2 times, we need to find the area of the base. So let's come over here and find the area of the base. We're going to do 4.8 times 1.9. This is 1.9, 4.8. So we'll go 4.8 times 1.9, and that would be the area of the base. 9.12 will be the area of the base. There are 2 of them, so I'm going to put 9.12 here into my little formula. Multiply it out. Multiply that by 2. I'm going to get 18.24. Add that to 30. And I'm going to get 48.24. And that is an 8. Sorry. And since I'm rounding to the nearest whole number, it rounds down to 48. 48 feet. And it will be feet squared. It is area. And that will be my surface area. All right, there's number 1. All right, number 2, we're finding the surface area of the cylinder. Now to find the surface area, we're once going to go the surface area. And you could think of it like the perimeter of the base. The perimeter of the base, when you're dealing with a cylinder, is a circle. And the perimeter of a circle is really the circumference. We know circumference is pi times diameter, or circumference you could say is 2 pi times the radius, because the diameter is 2 times the radius. So here, with the surface area, we're going to go the perimeter, which is either pi times diameter or 2 pi r. I believe your book uses this, but I'm going to go pi times diameter here because we're given the diameter. Okay, so we're going to do the perimeter of the base times the height, and then we're going to add both the top and the bottom. So 2 area of the bases, the top and the bottom. So we do the perimeter of the base times the height. The perimeter is the circumference. Pi times diameter times height. So we're going to go pi, and then our diameter here is 12. Our height here is 20, plus, that's supposed to be 20, plus 2 times the area of the base. Well, the base is a circle. Our base area is going to be pi r squared. So we come over here and we know the diameter is 12, so our radius is going to be 6, half of the diameter. So it's going to be 2 times pi times the radius squared, 6 squared. Now go ahead and just work this out on the calculator. We want it in terms of pi, so I don't need to multiply by 3.14. I'm going to leave it in terms of pi. So I'm going to go 20 times 12 times pi, which is going to give me 240 pi. And then I'm going to go 6 squared, which is 36, and multiply that by 2. That gives me 72 pi. Add those two together, 240 plus 72, and you're going to get 312 pi. And there is your surface area, and it is in terms of meters, so it's going to be meters squared. When we're dealing with area, it's always area squared. All right, number 3, we're going to cover this triangular prism with fabric for an art project. So you've got this triangular box, you're covering the whole thing, you're making it look nice. How much fabric will you need to the nearest whole inch? So when we're covering the whole surface area, we're looking for surface area. Okay, we know surface area for prisms is the perimeter of the base times the height plus 2 times the area of the base. So the top and the bottom will be the same. So we need the perimeter of the base, and we look here. We know this is 16, this is 12, but we don't know this here. But you can see the right angle marking there. So that means we have a right triangle, and we can use Pythagorean theorem to get this so that we can find the perimeter of the base. So we've got one more step. This right here, it's across from the right angle, so it's going to be the hypotenuse. So we're going to go a squared plus b squared equals c squared. So we'll go 16 squared plus 12 squared, slow to write with this, equals the hypotenuse squared. So we'll just call that c squared. All right, go ahead and work that out. 16 squared is going to be 256. 12 squared is going to be 144. And we're going to add those together. My writing's delayed. 256 plus 144 is going to give me 400. And then I'm going to square root this. And the square root of 400, I believe, is 20. So 20 will equal my hypotenuse. Now I can find the perimeter of the base. So I'm going to go 20 plus 12 plus 16. 20 plus 12 plus 16 is going to be the perimeter of my base, which is going to be 48. And then I multiply that by the height of the prism, 25. And then I want to add plus 2 times the area of the base. Well, the base is a triangle, and the area of a triangle is 1/2 times the base times the height. And I apologize for the writing on this, it's really bad. All right, so if you look at this triangle, because it's a right triangle, the base and the height are my legs. So I'm going to go 1/2 times my base, which is going to be 16, times my height, which will be 12. Or you can do it the opposite way, 12 and 16. Now let's just do the calculations on that. 1/2 of 16 is 8, and then 8 times 12 is 96. And then you multiply that by 2, and you get 192 here for this part. And then we'll go ahead and do 48 times 25, and we get 1200. And add those two together, and that's going to give you your surface area. And I don't know why it's so slow. So our surface area is going to be 1392, and it is inches, so it's going to be inches squared. Inches squared, and that's a 2 there. Okay, 1392 inches squared. We want to find the surface area of the pyramid. So looking at surface area of pyramids, we're going to look at it like this. The surface area of the pyramid is going to be, I don't know if I can get this thing to work. surface area of the pyramid is, okay. When we're looking at pyramids, it's going to be 1/2 the perimeter times the slant height. That is going to be our surface area. 1/2 the perimeter times the slant height plus the perimeter of the base. So our lateral area is going to be 1/2 the perimeter times the slant height. And you can think of it like you've got triangles on your faces. So it's 1/2 the base times the height. And the height of this triangle is the slant height. It's not the height of the pyramid. This will be the height of the pyramid, okay? So that's why it's the slant height. This is how we find the perimeter or the lateral area, excuse me. We're going to do, if I were just to define one triangle, it would be 1/2 the base times the height of this face of the triangle, which is the slant height. So we do the perimeter times the slant height times 1/2. Let's go ahead and find the perimeter. If this is 6 and it's a regular pyramid, all the sides are 6. So I'm going to go 6 times 4, which is 24. So my perimeter will be 24, and my slant height is given to me. It's 10. And I'm going to go 1/2 of that. And then I need to find the area of the base, and that should be pretty quick. Because it's a square, the area is just going to be 6 times 6, which is 36 meters squared. Just do the math on that. 1/2 of 24 is 12, and 12 times 10 should be 120. And then 120 plus 36, let's see if it lets me write this out any quicker. If I write too fast, it won't make the proper markings. All right, 120 plus 36 is going to be 156, and we're rounding to the nearest whole number, and it is a whole number. 156, and it's going to be meters squared. And that is what I got, meters squared. There you go. All right, on number 5, we are finding the slant height here. Find the slant height of the pyramid to the nearest tenth. So to get the slant height, we basically want the height of the face of this triangle right here. And so we create this right triangle inside the pyramid, and I'm going to draw it out here so we can see it. All right, so we know the height here is 10. This will be our slant height. We need to find this base in order to figure out the slant height. If you look here in our pyramid, the base is a square. If this is 5, halfway over is also going to be half of that. Not also, it is going to be half of that. So if this is 5, this will be half of 5, which is 2.5. And that will be, if I can get this to write correctly, 2.5. Okay, now we can figure out the slant height using Pythagorean theorem. So we just go 10 squared plus 2.5 squared. I apologize for the writing on this tool. It's just awful. It just doesn't work very well. Equals the slant height squared. And just work the math out on that. This is going to be 100. And then if you do 2.5 squared, 2.5 times 2.5 is going to be 6.25. That's a plus. 6.25. And that's going to equal your slant height squared. So work the math out on this. This is going to be 100, 106.25. And then you just have to take the square root of it, and I have to write really slow or else it doesn't write. And yeah, see, right, and then square root it. And if I square root 106.25 and take the square root of that, it's going to be approximately 10.3, and it wants to the nearest tenth, so we're going to go 10.3 will be our slant height, and that will be in meters. 10.3 meters is going to be our slant height, or L. Slowly write it. All right, there we go. All right, we're going to find number 6, the surface area of the cone in terms of pi. So if I want to look at the surface area, I'm going to, for the formula for the surface area of a cone, let's write that down. I got a new writing tool. I fixed this. Surface area of a cone is going to be pi times the radius times the slant height. And then I'm going to add the area of the base. So that will be the lateral, pi times the radius times the slant height. And then the area of the base. And the base is obviously a circle, so it's going to be pi r squared. Okay, so let's go ahead and find this. We need the radius. First of all, 12, I know it's pointed right here, but because you have this full dotted line, this is actually the diameter. So the radius here is going to be 6. All right, to find the surface area, I'm going to go pi times the radius, which is 6. Now I need the slant height. Well, I don't have that. I have the height of the cone. I need the slant height. I'm going to have to do Pythagorean. So if this is 8 and this is 6, I can figure out this. Now I know some Pythagorean triples off the top of my head, and if this is 6, this is 8, this has to be 10. It's a 6, 8, 10 triangle. If you don't know the Pythagorean triples off the top of your head, go ahead and work Pythagorean theorem on this. You're going to go 6 squared plus 8 squared is going to equal, if you don't know the Pythagorean triple, this would be your slant height, squared. 8 is 64, 8 squared is 64, 6 squared is 36, and slant height squared. And then 34 plus 36 is 100, and that's your slant height squared. And then you're going to square root both sides. 100 is your slant height, which is exactly what I just worked out. Hey. All right, so that is the area, or the slant area. Now we need the area of the base. So we have the slant height, which is 10. Now let's find the area of the base. The base is a circle, so the area is going to be, base area is going to be pi r squared, pi times the radius squared. And you know the radius is 6, so pi times 6 squared. 6 times 6 is 36, so your base will be 36 pi. We want to put this in terms of pi. So 6 times 10 is 60 times pi. This will be 60 pi plus 36 pi. Add those together, you're going to get 96 pi. And it is in terms of centimeters and its area, so it's centimeters squared. And there's your surface area. All right. All right, hopefully that's not too loud. My daughter's having drum lessons. All right, find the slant height of the cone to the nearest whole number. Slant height is just this height right here on the face of this cone. So you're basically going to take the inside height and this radius to make a triangle and find the slant height. So let's go ahead and draw our triangle. This will be 16 centimeters, 12 centimeters, and then the slant height. Once again, Pythagorean theorem, you're going to use that a ton. 12 squared plus 16 squared is L squared. Do the math. 144 plus what's 16 squared? 256. Just double checking. I was right. 256 is your lateral, your slant height. And then you're going to add 256 and 144, and you're going to get 400. And this is very similar to that last one we did. Square root, 20 is your lateral or your slant height. So the slant height of this cone is 20 centimeters. All right, on to number 8. Let's clear this off. Number 8 asks you to find the volume of this prism, round to the nearest tenth. Let's write out the volume formula. For prisms, the volume is the area of the base times the height. So let's go ahead and do the volume here. If this is 6, then this right here is 6. So to find the area of this base, we're going to go 7, and that will be meters. 7 meters times 6 meters. And that will be the area of the base. Because it's a rectangle, we just do 7 times 6. And then the height of the prism is 15. So we just go 7 times 6 times 15 and do that on a calculator. And you're going to get 630. And since we did 7 meters times 6 meters times 15 meters, it's meter, 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 meters cubed. Your volume is cubic meters. All right, let's go on to number 9. Number 9 asks us once again to find the volume of the given prism round to the nearest tenth. All right, this time this prism is laying on its side. So careful about where the prism is laying. Because it's laying on the side, you actually have one of the lateral faces. It's not the base. So this can get tricky. Your base is actually these triangles, okay? So make sure you only have two bases. This is how you can tell. If you look, this has a base and then it has a triangle and it has, excuse me, a rectangular side here and a rectangular side here. So it's almost like it would have three bases. You should only have two bases, the top and the bottom of your base. So this is a triangular prism laying on its side, okay, instead of upright. So once again, the volume for a prism is going to be area of the base times the height. Well, here your base is a triangle. These are your bases, okay? So since my base is a triangle, the area of the base is going to be 1/2 base times height, meaning little base. Little b meaning the base of this triangle. So it's going to be 1/2. The base of the triangle is 3. It's a right triangle, so my height is right here, 4.2. Now that is the area of the base, and I multiply that by the height of the prism. And if I tip this up, you can see this is the height of the prism, 9. And I'm going to go ahead and do the math on that. So if I do 3 times 4.2 and then divide that by 2 and then multiply that by 9, I'm going to get 56.7, and this would have been centimeters, 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 so that'll be centimeters cubed. So when we're rounding to the nearest tenth, it actually is already rounded. That's our volume, 56.7 centimeters cubed. All right, on to number 9. All right, find the volume of the cylinder in terms of pi. Volume of cylinder, let's write out that formula. It's once again the area of the base times the height. This is also laying on its side. These are the bases. The two circles are the bases. So careful how it's laying. So since my bases are circles, the area of the base is going to be pi r squared times the height. All right, so we need the radius, and we are given the radius, not the diameter. We're given the radius. Nice. We just really have to plug it in. These aren't too tricky. Pi times 4.5 squared times my height, and my height is 8.5 centimeters. Do the math on that. Use a calculator. 8.5 times, and then we're going to go 4.5 times 4.5 to square it. And then we're going to multiply that by pi, and they want the answer in terms of pi. So we're just going to go 172.125 pi is the solution I get. If you want to round this to a tenth and go 172.1 pi, also fine. And because we're in centimeters, it's centimeters squared plus another centimeter. So it's going to be centimeters cubed. Volume is always cubic. All right, on to the next one, guys. Let's go number 11. Find the volume of this square pyramid, round to the nearest tenth. Volumes of pyramids. Now, pyramids are basically a third of a cone, or excuse me, of a prism. It's like I could fit another pyramid here and another one here, if you want to think of it like that. It's basically like a third of a prism. So remembering that, you can just go, all right, well, volume is going to be a third of the volume of a prism, which is the area of the base times the height. Our base is a square. Nice. Those are easy. So my base is going to be 3 times 3. That's how you find the area of a square. 3 times 3, or 3 squared. And my height they give to me is 5. So really, so basic. You just have to know the formulas. 3 squared is 9. 9 times 5 is 45. And then I'm going to divide that by 3. And I'm going to get my volume, which is 15. And this is centimeters, centimeters, centimeters. So centimeters cubed. And my daughter's playing the drums. Oh, wow. Okay. Okay, let's find the volume of square pyramid with base edge of 5 meters and slant height of 14.2. Round to the nearest tenth. So we've got a pyramid and the base edges are 5. So these are 5. And we know it has a slant height of 14.2. So with this pyramid, All right. We're not given the height, which would be the center, and that's what we need to find the volume of the pyramid. We're given the slant height right here, the face height. So let me do that in another color. We're giving the height of the face, and we need the height of the pyramid. So we need to figure out the slant height using Pythagorean theorem. Using the slant height with Pythagorean theorem, we need to figure out the height, the h. So if they tell us the slant height is 14.2, if we pull out this little triangle guy, and we worked on this in a couple other problems, if this is 14.2 and this is the height we need, we know this base. If this is 5, this is going to be half of that, 2.5. So we're just going to go height squared plus 2.5 squared is going to equal 14.2 squared. Or a squared plus b squared equals c squared. And just do the math on that. 14.2 times 14.2 is going to be 201.64. 2.5 times 2.5 is 6.25. Height squared plus this equals this. Now I'm going to go 201.64 and subtract off 6.25. So subtract this to this side, and I'm going to get height squared equals 195, that's a 9, 0.39. And then I want the height, so I take the square root of 195.39, so square root of that, and I'm going to get my height. It's approximate. I'm going to approximate my height 13.97. If I do 13.9 and round to the nearest tenth, 13.97 actually rounds this up to 14 because it's going to kick this up to 10, it's going to kick that up. So the height is approximately 14. All right, depending on how you round your height, you might get a little bit different volume. So volume, once again, is 1/3 times the area of the base times the height. So my base is a square, the area is going to be 5 times 5. So 1/3 times 5 squared times the height, which is 14. Go ahead and do the math on that. 5 squared is 25 times 14, and then divide that by 3. And we're going to get an approximate, and I'm going to write it over this way, an approximate of 116.6, okay, to the nearest tenth. Depending on how you round your height, might change this a little bit. If you did 13.9, you're going to get like 115 point something. So depending on how you round your height, oh my gosh, my daughter in her drum. Depending on how you round your height. I don't know if you guys can hear that. All right. So it's going to be meters, meters, and meters. So it's going to be meters cubed. And that's your volume. All right. Let's do... Okay, if you want to find the volume of an oblique cone, it's the same as the volume of a regular cone. You're just taking that cone, if it was like this, and you just shove it over a little. The volume's going to be the same, the area that fits inside. So your volume is still going to be 1/3 times the area of the base times the height. So we're going to go 1/3. Your base is a circle, so your radius is going to be, or your area of the base is going to be pi times your radius, which is 10 squared. Now you need to multiply that by the height, and they give you the height. So nice of them. Okay, it's not this slant height, which you could try to figure out using Pythagorean. It's the height right here. Okay, so times 12. All right, and just do the math on this. They want it rounded to the nearest meter, so we're going to round out pi. We're going to go 10 times 10 is 100, so 100 times 12. And then go ahead and divide that by 3 and multiply that by pi. And you should get somewhere around 1256.6, and it's meters, and we did meters squared times meters, so always cubic meters, and there's your volume. I was supposed to round to the nearest meter, and I rounded to the nearest tenth of a meter, so it's actually 12. Oh my gosh, that's so loud. Oh, it's okay. Come here. 1257 meters cubed. All right. Hey. Okay, number 14, find the volume of the right cone shown in terms of pi. So it's a right cone. Once again, same volume as the oblique cone. So 1/3 the area of the base times the height. Your base is a circle, and this is pointing to the diameter. Because it's dotted all the way across, you can assume this is the diameter. So the radius would be 4, right? And they went ahead and gave us the actual height of the cone, not the slant height. Yay! So we don't have to do Pythagorean theorem. We have everything we need. So we're going to go 1/3. The base is a circle, so the area of the base is going to be pi r squared, and our radius is 4. So pi times 4 squared times the height of the cone, which is 12. Go ahead and do the math on that. We're just going to go 4 squared, which is 16, times 12. And then go ahead and divide that by 3. And we're going to get 64 pi. Since it's in terms of pi, we don't have to multiply by 3.14. It's just 64 pi. And it's meters, meters, and this would be meters. So meters and blah. This is meters because it's the radius. So meters times meters times meters is going to be meters cubed. Volume is always cubic meters. All right. Hello. Ooh, hello. All right. We want to find the surface area of a sphere with the diameter of 14 inches. And your sphere, dun, 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 is going to be, the diameter will be of the great circle, which is the slice straight through the center. So if the diameter is 14, the radius will be 7. All right, leave your answer in terms of pi. So you need to know the formula for the surface area of a sphere. Surface area is 4 pi times the radius squared. You need to know that formula. And if you know the formula, these are easy. You just plug in the numbers. 4 times pi, they give us the diameter, which is 14. The radius is 7. 7 squared, and just do the math. 7 squared is 49 times 4, and that's 196, and multiply that by pi, 196 pi, and because we're dealing in inches, this is going to be inches times inches, which is inches squared. Area is always square inches. All right, 196 pi inches squared. All right, number 17, find the volume of the sphere in the following diagram. Give your answer rounded to the nearest cubic millimeter. All right, volume now. We got to know the formula for volume, not surface area, but volume. Volume of a sphere is 4/3 pi r cubed. Make sure you know the formula for volume of a sphere. We have the radius here. It's just a plug and chug. This is a super easy problem. Pi times your radius, which is 6, and you're going to cube that. All right, do the math on that. Just grab a calculator and do 6 times 6 times 6, or 6 cubed if your calculator does that. Multiply that by 4, divide that by 3, and then we want rounded to the nearest cubic millimeter, so we do want to multiply out pi also. And we're going to get an approximation rounded to the nearest cubic millimeter, 904.7. which I'm going to round to 905 millimeters, and it will be cubed. And there's your solution for that one. Let's go ahead and look at number 18. Number 18, you need to cover a whole surface of a cylindrical container with paper for an art project. So the whole surface, not just the lateral surface. So let's say you had some art project where you had to cover some cylinder that you're using for pencils. No, that one you wouldn't cover top and bottom. It would be more like a present box, all right? You're covering the whole thing top and bottom, all right? The cylinder has a radius of 12, so let's just sketch out a cylinder here. And we have some drumming still. Drumming, drumming, drumming. All right. Sorry for the drumming. Really gotta get this done right now though. Okay, because I want you guys to have it before it gets too late. All right, the radius is 12 here, and the height is 7. To the nearest hole, draw pictures always, guys. That totally helps. Draw pictures. If it's not given a picture, draw a picture. To the nearest whole number, find the area of the paper. Round to the nearest whole number. Wow, I said that twice. I'm sorry. I should fix that. All right, surface area. We're looking for surface area, so go back to the surface area of a cylinder. To get the surface area, you need the lateral area and the height, or excuse me, the lateral area and then the two bases. To get the lateral area, you do the perimeter of the base times the height. Like if you slice this and roll it out, it's going to be a rectangle, which will be the perimeter of the base, which ends up being just your circumference. And you know circumference is 2 pi r, or pi times diameter, either way. Okay. So surface area, once again, perimeter of the base times the height plus the top and the bottom, the 2 times the area of the base. All right. Your perimeter of the base, well, it's a circle, so the perimeter is the circumference. So it's 2 pi r. So 2 times pi times your radius, which is 12. And then the height is 7, plus 2 times the area of the base. Well, the base is a circle. The area of the base is going to be pi r squared. Our radius is 12, so it's going to be pi times 12 squared. It's getting slow again. All right, just do the math on this. This is just calculations. We're going to go, we want it to the nearest whole number, so we're going to multiply out pi. So we're going to go 12 times 7 times pi times 2. Just multiply that out on a calculator. 2 times 7 times 12 times pi. And that's going to give approximately 527.78. I'm going to keep my decimals here and I'm going to round at the end. We got 12 times 12 times 2 times pi. And that's going to give me approximation of 904.77. Add those together. 527.78. And we're going to get approximately 1432.5. So 1433 if you round up. If you didn't round these, you would end up with 1432. So it's fine if you have either answer. And that's going to be centimeters squared because we're dealing with area. So 1433, or if you rounded those down, you would end up with 1432. Either of these are fine. All right, either of those. Okay, on to the last two. Okay, 19. The approximate dimensions of an Olympic-sized swimming pool are 146 feet by 82 feet by 6.6 feet. Okay, so we're talking about depth too. All right, and I'm guessing it's rectangular. Okay, so we'll do 82 by 164, and then because we're talking depth here, like how deep the pool is, right? We're doing depth too. So this depth is going to be 6.6 feet deep all the way across. All right. Find the volume of the pool to the nearest cubic foot. Well, that's easy. Volume is just going to be the area of the base times the height. Well, the base is going to be 82 times 164. So, and then a height is 6.6. So to do that, we're just going to go volume equals 82 times 164 times 6.6. Multiply that out. 82 times 164 times 6.6. And the volume is going to be an approximately 88756 to the nearest cubic foot, 88756.8. So I'm going to round this up to 7. Okay, 88,757 cubic feet. There's your volume, so that's part A. Now part B says if 1 cubic foot is 748 gallons, about how many gallons does the pool hold? Well, if 1 cubic foot is 748 gallons and I have 88,757 cubic feet, I'm going to have to multiply each of those cubic feet by 7.48 gallons. So I'm going to go 88,757 times 7.48 gallons. All right. 88,757 times 7.48, and that's going to give me a really big number. And we're going to round to the nearest cubic gallon. We'll round to the nearest gallon. So let's just go, it's 0.36, so we'll just end it there. And we'll say gallons. All right, 663,902 gallons. That's a lot of water to fill up that pool. All right, and just round that to 663,902 gallons. So that would be part B. All right, last one. A spherical scoop of ice cream with a diameter of 4 rests on top of a sugar cone that's 10 centimeters deep. So we got an ice cream on top of a cone, yum, right? It has a diameter of 4, so it would have a radius of 2. And the height of the cone is going to be 10. Okay, that's 10. Right? If all the ice cream melts into the cone, what percent of the cone is filled? So we want to know how much, what's the volume of that sphere or the ice cream, and what's the volume of the cone, and can it melt into the cone? How much of that cone will fill up? Okay, good question. First thing we want to do is find the volume of the cone. Okay, we know how to find the volume of the cone. I want you to explain your method and the formula you use. So tell me the volume of the cone. Volume of cone, if I want to find volume, I'm going to do 1/3 times the area of the base times the height. Now my base is a circle, so I'm going to do the volume is 1/3 times the base, which will be pi r squared. Because it's a circle, that's how I find the area of a circle. My radius is 2, I square it, and then I multiply that times the height. Okay, go ahead and do the math on this. If you square 2, you get 4. 4 times, and the height, I'm going to come back and do the height. Sorry, the height here is 10. Okay. So 2 squared is 4, and then I'm going to multiply that by 10. Then I'm going to divide that by 3, and I'm going to multiply that by pi. And I'm going to get an approximation of 41.88. I'm going to round that to approximately 42. Because I'm dealing with volume, I'm going to have that in centimeters cubed. All right, so there's part A. Let's do part B. Part B asks for the volume of the ice cream. So that's a sphere. Explain our method used. Well, volume of a sphere is going to be 4/3 pi r cubed. So let's find it. We know the radius of the sphere is 2. We're going to go 4/3 pi times the radius, which is 2, and we're going to cube that. Now do the math on that. 2 cubed is going to be 8 times 4, divide that by 3, multiply that by pi, and we're getting an approximation of 33.5. You can round that to approximately 34, and it's going to also be centimeters cubed. All right, so there's part B. We have part A and part B. Now part C asks us what percent of the cone will be filled with the melted ice cream. Explain how you found the percent. So to get a percent, we want, percent means out of 100, okay? So we want a percent out of the whole. So our whole amount will be the cone. Okay, that's our whole amount. And then the ice cream is our part. So we want our part out of our whole, all right? So we're gonna take our ice cream, and we're going to divide ice cream, so IC for ice cream, by cone. And then hold on, I can't get that to move. Let me see if I can move this over a bit. Just my face is in the way. Hold on. All right, I'm going to divide the ice cream by the cone. I'm going to write it up here because I've run out of room. So ice cream by the cone. The cone is the whole. I'm going to take the part to the whole. So the ice cream part was part B. So my ice cream was 34 centimeters cubed. And I'm going to divide that by the cone part. The cone part was 42 centimeters cubed. Go ahead and divide those out on a calculator. 34 divided by 42, and that's going to give me an approximation of 80.9. So you could say 80% or 81%, approximately 80%. So when I divide this out, I do get 0.8095. Move the decimal 2 places, and you're going to get 80.95%. Okay, you could round that up to 81. Depending on how you rounded these could determine how that rounds, but approximately 81% of the cone will be filled if all of the ice cream melts. So you won't overfill the cone. And there you have it, folks. That is the rest, or that is Practice Benchmark, Chapter 9 for Integrated Math 2. Good luck on your test. Come to tutoring on Thursday if you need any more help, and I will see you later.